Alright, so for this problem, okay, this right here is going to be an intro. Practically, this is as hard as I can make these problems. Okay, if you follow the steps, you'll be fine. So go with the steps. So, here's a question. What is the energy of a photon of light that has a wavelength of 506.12 nanometers? First thing you need to be looking at is, what am I asking you for? I'm asking you for energy. So, first thing, energy. What are you doing? Alright, energy. So, oh, Bryce, be quiet. Alright, so energy. You're looking for energy. So, what's the formula you're going to use? Energy equals Planck's constant times nu. Okay, it's the funny looking V. With this, you got a problem. You know Planck's constant, but you don't know nu. You have to find out your frequency. You have to find this. How are you going to find it?
Mr. Kennedy, call the office.
Okay. So, nope. I'm trying to find energy, though. You're going to use the other formula. You're going to use the speed of light equals wavelength, which is lambda, times nu, which is the frequency. Well, yeah, there you go. Do some algebra. Yeah, you're right. You're right. Stop looking at me like you're wrong.
I'm so confused.
Wow, you just guessed it right.
I don't know.
All right, frequency equals the speed of light divided by wavelength. Okay? Any questions behind how I got to there?
I think I got to search.
I don't even know. Okay. All right. So, let's go with this. Let's find frequency. What's the speed of light? 2.98 times 10 to the 8 meters per second. That's going to be divided by my wavelength. There's a problem. There's a prefix there. Nano. There's not a prefix here. You can't just do a straight up division. Yeah, you could have said that. That's okay.
So would you have to like convert it with that little conversion thing?
Yes. You got to do the metric conversion.
The sheet and
Yeah.
the numbers.
The table. Remember what I told you. Once you learn something in here, don't forget it.
I don't forget about studying again.
Okay, I don't know how we're forgetting it, but alright. So you're going to divide it. I'm not going to write it out. I'm just going to do this. I'm going to use my method. So 506.12 times 10 to the negative 9 meters.
Brady,
So you're left with inverse seconds.
Brady, what'd you do?
There's my calculator. Alright.
How old you have?
I hope y'all are writing this down, because this is the only problem I'm working out.
Yeah.
What is the energy of where's the
So divided by 506.2 second E negative 9, and you find out that its frequency is 5.8879 times 10 to the 14th hertz. Any questions how I got there?
No.
Anything?
So let's see.
Okay. On delay. Don't worry about writing the question right now. Just write that down, because I need to erase that. Because I don't want to erase this. This is going to come useful. But here, I'll just do it here. I'm doing it in a
That
different
video
color.
is getting on that on today.
It is. Every bit of it. Alright. Now you got frequency, right? Now you're ready to find energy. So energy equals Planck's constant times frequency. Planck's constant, you ain't learned it yet, you better learn it by Friday. equals 6.626 times 10 to the negative 34 joule seconds times your frequency you just calculated. You are driving me nuts, Garrett. Quit. 5.8879 times 10 to the 14th hertz. Hertz and seconds cancel, leaves you with joules, which is what you want. Go back to your calculator and multiply it out. And you find 3.9013 times 10 to the negative 19 joules. Stop smacking the meter sticks. Gosh, I feel like I'm teaching kindergarten right now.
So that's
Am I done?
No, I feel like you're not.
Why?
yeah, you
Yeah,
found the energy, right?
I think it's because he circled his answer. You're done.
I'm done. Because of what Dominique said. I'm looking for energy. I found energy. Okay, I'm good. I'm done. Alright? Are there any questions on that, how I solved that? Because I'm going to ask you 2 additional questions with it.
So what if they ask you for like something else?
Do what?
Is that what you're gonna ask for
Can
energy?
you move that back?
Or if you ask for the signal?
I can ask you for anything. I can ask you for energy, wavelength, or frequency. If I'm asking you for frequency, or I've given you frequency, it's a one-step problem. If I ask you for wavelength, or I ask you for energy, you're looking at two steps. If I haven't given you frequency. Okay, in this problem, I'm asking you for energy, but I gave you wavelength. You automatically know it should be a 2-step problem. Yes.
Can I stand out after? I'm doing this.
Yeah. Just put it over there on the side. Alright, any other question? Can I erase this part? No?
It's in the video, y'all can do it.
Come on, come on, come on.
We got on the own.
Alright, I'm gonna write the question in green.
It is scary.
It shouldn't be scary. It'll be fine.
Something about done.
Promise you not. Huh?
Something about
First
done.
of all, it starts to work.
Once you get that number, I'm gonna write it.
Okay. Go on.
Okay. Alright, so an additional question. And this is an easy trick question. Yep. So, are these photons deadly, harmful, if you like it that way, to humans? Yes or no, and explain.
Well, sure. You have to look at that thing.
Well, you tell me.
What even is a joule?
It's a unit of energy. Huh?
Because I can't see it.
Yeah, you can do that. That's fine. All right, is it deadly or not?
Yeah. I don't know. I don't think so.
Give me. Yeah, you're fine. You go.
Okay, 3 point, what?
Deadly or not? I gotta have an answer now.
Yes, highly deadly, yes.
I'm here no. I'm here highly deadly.
Yeah.
Okay, so there's just. Okay, here's the trick. How many of y'all are looking at this?
Yeah.
Don't look at
Looking
that.
at the 10 to the negative
I look
19.
at the 506. Ha!
The nanometer.
Look at that. I will have to give you that electromagnetic spectrum. If I ask you a question like this on Friday, I have to give that to you. But take a look at it. Sorry, YouTube. You can't see the electromagnetic spectrum. Look it up. Use Google. Alright. Look at that. 506.12 nanometers. where does that fall on here? Where do things start getting deadly?
It's invisible light.
It's like
Is what it falls.
It starts to get deadly ultraviolet light. So if we have not reached that point in our wavelength,
extra purple.
We're fine.
then it don't matter. It's not deadly though.
That would fall into
So get here,
blue.
506.12 nanometers.
It's blue.
Here's 500. There's 600. So it's sitting right in here somewhere. So you're looking right around there between
Blue.
blue. Okay, you're looking at blue. All right. So that'll give me the second question I'm going to ask.
What's the answer to the first one?
No.
Why not?
No. Why?
Because not
I said,
not ultraviolet
because not ultraviolet
rays or higher. Remember? Remember when we talked about it? The ultraviolet lights are harmful. Okay, and as you keep going, those waves can penetrate deeper and deeper into our bodies. Like ultraviolet light, it can only give us skin cancer, but it can't get past our skin. But then we get into like X-rays, and what do we use them for? To look at our bones. Okay, so that's what you're looking at. Yeah, it can give you all sorts of stuff. So this is the second question I can ask you on this. What color of light are these photons? Now, with this, I can change that. No, you still look right here.
So it's blue.
Never gonna even
If you're using the electromagnetic spectrum, look for wavelength. Now, I can give you energy and make you work backwards to wavelength. It's just the same step, just different. It's the same. It's a two-step problem. You guys are so stressed over
I
that.
like blue.
It's blue.
Just call it blue.
It's blue.
Okay. What color of light? I was like, what is that? What color of light are these photons? They're blue. Okay. So the answer there would be blue.
It was like 4.
Now I can change it and I can ask you what type of rays does this represent? If I say that, it can be anything up there. It can be radio, radar, microwave, infrared, visible light, ultraviolet, X-rays, gamma rays, cosmic rays. I can ask you, I'll make for sure that if the numbers will work out to the point to where it'll be good for you. Is there any questions with this problem?